Hi, everyone. Welcome to the Septic System 101 webinar. My name is Andrea Alberton, and I'm the Regional Water Resources Extension Agent in the Northwest Extension District. So I cover the Florida Panhandle. Today, my colleague, Dr. Yilin Zhuang, the Water Resources Regional Specialized Agent in the Central District, and I will teach this webinar. This webinar is part of an extension program called the Florida Well Owner Network Program. If you have not heard of extension before, you may wonder what it is. The Florida Cooperative Extension Service is a partnership between state, federal, and county governments to provide science-based, research-based knowledge to the public. The University of Florida, together with the Florida A&M University, administers the Florida Cooperative Extension Service. There is at least one extension office in each county in Florida, and I'm the University of Florida, as I mentioned before, regional agent for the Northwest District, which covers 16 counties in the Panhandle. These are highlighted in yellow on the map. Dr. Zhuang is the specialized agent in water resources for the Central District, which includes 11 counties, and is highlighted in orange on this map. There are a total of 5 extension districts in Florida. As I mentioned earlier, this webinar is part of the Florida Well Owner Network. What is this network? It's a program that aims to educate residents about well water quality and quantity and best practices to ensure well maintenance and groundwater protection. We also want to facilitate access to well water testing and provide information about treatment options if problems are found. Finally, the purpose of this program is to complement efforts by the Florida Department of Health and the Florida Department of Environmental Protection to increase awareness among Floridians about best practices regarding their wells, septic systems, and drinking water quality. So why did we develop the Well Owner Network? Why did we feel there was a need? Basically, there are a lot of Floridians that rely on private well systems in Florida for home consumption. It's estimated that at least 2.5 million residents, about 12% of the population, rely on private systems for water. There are approximately 800,000 private wells in Florida, and this is a conservative estimate by the Department of Health. Private well users manage and protect the water quality in their wells because US EPA safe drinking water regulations do not apply to residential wells. So the residents are in charge of ensuring that their well water is safe to drink. Private wells in Florida are under the purview of the Department of Health. They provide information to well users, and some county health departments offer water quality testing services as well. If they don't provide testing, they can point you to a commercial certified lab. Many areas, they also provide septic systems permits for new well construction and repair. However, depending on where you live in Florida, water management districts may also be the entities in charge of permitting. The Florida Department of Health has a program called the Well Surveillance Program that it runs together with the Department of Environmental Protection. The program identifies and monitors threats to drinking water supply. It ensures that contaminated sites posing the greatest risk get cleaned up first, and the program prevents long-term consumption of contaminated drinking water. These threats are usually man-made contaminants, such as the pesticide EDB or ethylene dibromide is an example that's monitored in certain parts of Florida. Other contaminants are monitored in different parts, just depending on where you are. Finally, very little public data exists on how many well users regularly test their water or drink from contaminated wells. So what about septic systems in Florida? Because well users generally have septic systems for wastewater treatment. Nearly 1 in 3 households in Florida depend on septic systems to treat wastewater. There are more than 2.5 million septic systems in use across the state, so we definitely have a lot of systems throughout Florida. And finally, the Department of Environmental Protection has identified septic systems as major sources of nitrogen to many impaired water bodies in Florida. So in this presentation, which is focused on septic systems, what will we cover? Dr. Zhuang will give an overview of why we are concerned about septic systems in Florida and how conventional septic systems work. Then I will talk about the 2016 Florida Water Bill and impacts on septic systems regulations, as well as provide information on advanced nitrogen-reducing technologies and resources available here in Florida. Finally, Dr. Zhuang will finish the presentation talking about recommended septic system maintenance to ensure that the system functions as it should. Okay, I will now hand the presentation off to Elin.
Thank you, Andrea. All right, first, let's clarify some terminology. Septic systems are also called on-site sewer treatment and disposal systems, or short, we use OSTDS, and sometimes we just call it septic tank. So during this webinar, we'll call it septic systems, the term we are more used to it. So how prevalent are septic systems in Florida? So it is estimated about 1/3 of the population relies on a septic system for wastewater removal. And please note, these septic systems are not just in rural areas. From this map created by the Florida Department of Health, you can tell even in cities, you can find the septic systems. Septic systems are designed from a public health perspective. The conventional septic systems, like the diagram shown on the right, are common in Florida. They are most effective in removing pathogens, but they are not designed to remove nutrients, such as nitrogen and phosphorus. Even a properly sited and maintained conventional septic system is a source of nitrogen to surrounding soil and can lead to groundwater. So in next few slides, we'll get into more details what conventional septic systems look like and how they work. A conventional septic system has two parts, septic tank and drain field. So first, let's have a look at the septic tank. Septic tank is a watertight container. It is designed for the size and expected usage of the home. When the household sewer enters the tank, solids or organic matters break down and settle to the bottom. Oil and grease rise to the top, and the middle layer is the liquid layer, which is the effluent that moves on to the drain field. The common materials of septic tanks are concrete, and recently we're seeing more tanks made of plastics, such as polyethylene, because it's lighter and easier to transport. The size of the tank depends on the number of bedrooms. In the next slide, I will show you what the code requires. Septic tanks are typically 2 feet below the surface and at least 50 feet from a drinking well. I put a star after 50 feet because Florida code requires 75 feet, but it says the septic system should be at least 75 feet away from a drinking well. And we know a septic system includes both a tank and a drain field. The 50 feet setback is adopted from other extension publications, which recommends a minimum setback at 50 feet between the tank and a drinking well, and 100 feet between the drain field and a well. Also, a septic tank is usually 10 to 15 feet from the house. So here is the Florida code. According to the Florida code, septic tank size is determined by the numbers of bedrooms. For example, if your house has 2 bedrooms, the minimum size of your tank is 900 gallons. If you have 3 bedrooms, the minimum size of your tank is 1,050 gallons. Now let's have a look at the drain field. Drain field is also called leach field, soil absorption field. Most treatment takes place here. Drain field is a series of trenches or perforated pipes. Contaminants are removed, filtered, and transformed as the effluent moves through the soil. Drain field is usually buried 1 to 3 feet below the surface and requires unsaturated soil. The code requires at least a 24-inch distance from the bottom of the drain field to the highest water table or the wet season high water table. If the 24-inch distance cannot be met, the drain field will be mounted. Instead of gravity-fed, effluent will be pumped up to the drain field. As I mentioned earlier, conventional septic systems are most effective in removing pathogens, non-nutrients like nitrogen. So how much nitrogen flows out of a septic system? First, we need to know how much nitrogen flows in per day. It is estimated one person produces about 11 grams of nitrogen, which translates to about 9 pounds of nitrogen per year. The majority of this nitrogen comes from toilets, but we also produce nitrogen from baths, sinks, appliances, and kitchen sinks. A typical conventional septic system can remove about 30% of nitrogen, which means 6 pounds of nitrogen is leaching or potentially leaching into the groundwater per person per year. It does not seem like much on a per system base, but when we consider a spring basin or a watershed, the numbers add up. Phosphorus is a little different from nitrogen. A conventional septic system can remove about 80% of phosphorus input. It is estimated one person produces around 2.2 pounds of phosphorus per year, with 80% phosphorus removal rate. About 0.4 pound of phosphorus is potentially leaching into the groundwater per person per year. The numbers that we showed you earlier are a functional system. Septic systems can create a much bigger problem when they fail. Poor design and the placement of the system is one of the reasons why the systems fail. For example, a functional system requires appropriate soils. We need them to drain well, but not too quickly, then it's unable to remove pathogens. Another design, the improper design is related to the rising groundwater level, because the rising groundwater levels may reduce the available vertical distance and cause water flowing away from the drain field. Code requires at least a 24-inch distance between the bottom of the drain field and the highest water table. For example, effluent initially flowing downward from the drain field and then encounters the groundwater. Also, some slope is needed to allow gravity-fed effluent flow to the drain field. But if it's too deep, water moves too quickly and will not all percolate into the drain field. Other factors causing a failing septic system including lack of or no routine maintenance, or overuse of water in the household and stressed system. Later in this presentation, we'll give you some suggestions on proper septic system maintenance. Septic systems are often out of sight. Here are some signs to tell you if your septic system is failing. So the first sign is if you smell rotten egg smell or sulfur smell close to your house, close to your system, or inside your house. Another sign is water and sometimes solids surfacing the drain field, or sewage backing up in the house, or your well water tests showing high level of nitrates or coliform bacteria. These are the signs showing you may have a failing septic system. Keep in mind, Leaching from septic systems is one source of excessive nitrogen and phosphorus to water bodies, and one source of nitrogen and phosphorus that can lead to water quality deterioration.
Thank you, Elin. I'm now going to talk about the 2016 Florida Water Bill, which was our new water bill that was passed. And provisions in this bill do affect septic system regulations throughout the state, particularly since septic systems were identified as potential sources of nitrogen, excess nitrogen to water bodies. So the 2016 water bill created the Springs and Aquifer Protection Act, which in turn created a new category of protected waters in the state, our outstanding Florida springs. These are 30 of the largest springs in the state with flows of greater than or equal to 100 cubic feet per second, which is about 64 million gallons per day. Several second magnitude springs with flows of 10 to 100 cubic feet per second were also given this special protection. So 24 of our 30 outstanding springs have been identified by the Department of Environmental Protection as being nitrogen impaired. This means that the spring ecosystem has been negatively impacted by increased nitrogen levels. To reduce the impact of excess nitrogen, target nitrogen loads were set. So targets of where nitrogen concentrations should be restored to in each system. Basin Management Action Plans, or BMAPs, were developed, which are restoration plans with actions that outline how to restore, how to reduce nitrogen concentrations in spring systems and other impaired water bodies. As I mentioned just now, Basin Management Action Plans were developed, which again are roadmaps of actions that outline how to restore and how to reach water quality goals in watersheds and spring sheds, how to reduce these concentrations in systems and other impaired water bodies to where they're no longer harmful to the spring ecosystem. So the areas in green on the map identify areas with a basin management action plan. Again, these areas here, they identify areas that are set to restore impaired water bodies within them. In this presentation, we're focusing on nitrogen impacts, but water bodies can be listed as impaired due to other nutrients like phosphorus, metals like mercury, and bacteria. One water body can also be identified as having multiple impairments or pollutants that need to be addressed. These BMAPs that have been established throughout Florida place more than 14 million acres under basin management. And this affects about 6.5 million residents that live within a BMAP area. I want you to take a look. I have just highlighted one BMAP in the north part of Florida. This is the Wakulla Springs BMAP, and I'm going to talk a little bit about this particular BMAP in the next slide. So within each BMAP, so for example, the dotted line delineates the Wakulla Springs BMAP area. Within each BMAP, and in this case the Wakulla Springs has been identified as being impaired by excess nitrogen, and I have marked it here with that bright yellow star. Within each BMAP, a priority focus area, or a PFA, is delineated where restoration activities are initially focused. The PFA is in the area of the spring shed identified to be the most prone to nitrogen loading to the spring system. This is often due to hydrology, proximity to the spring system, land use, and other factors. Here on this map, the priority focused area is, it's hard to point out, but it's outlined by this sort of orange, light orange, dark yellow line going around this closer to Wakulla Springs. So this is the priority focus area where restoration activities are focused. The next step that the Environmental Protection Agency, the Florida Department of Environmental Protection takes is to identify the major sources of nitrogen in this spring shed, in this BMAP, and target restoration activities on these sources. So for example, in the McCullough Springs BMAP, you can see on this pie chart different sources of nitrogen that were identified, as well as the percentage of each source that they estimate is affecting the spring. If septic systems contribute 20% or more of nitrogen loads, then a septic system remediation plan must be put into place. In this case, you can see that McCullough Springs, it was identified that septic systems contribute 34% of the nitrogen load to that spring system. So it has a septic system remediation plan within that priority focus area in place. So what do these remediation plans entail? Basically, if sewer is already available in lots in the priority focus area, newer repair permits will not be issued for septic systems. Connections to sewer service is required when such service is available. If sewer is not available yet and the lot is less than 1 acre size within the PFA, installation of new systems must include enhanced nitrogen treatment. For existing systems, if you're replacing, repairing, or modifying the system, must also include enhanced nitrogen treatment. So how do you know if you live within a BMAP priority focus area? The Florida Department of Environmental Protection, or FDEP, has an interactive map. We've listed the link here, where you can type your home address in the search bar, highlighted out here in red, and you'll be able to then see if your property is located within a PFA. On this map, BMAPs are identified in the darker sort of teal green color, that larger area, and the PFAs are in bright green, that neon green within them. So this is an excellent way to be able to know yes or no, you do or do not live within a priority focus area. So as we mentioned before, areas with septic system remediation plans, advanced nitrogen reducing systems are required for new construction as well as replacement of failed systems. These are the major types of advanced nitrogen reducing systems that are approved by the Florida Department of Health and the Florida Department of Environmental Protection for installation in Florida. They include aerobic treatment units, or ATUs, nitrogen reducing performance-based treatment systems, or PBTS, and in-ground nitrogen reducing biofilters, or INRBs. We'll take a closer look at each one briefly in the next couple of slides. So what do advanced treatment technologies generally look like and tend to do? What they do is they add steps to the conventional septic system to improve contaminant removal. In the case of Florida, septic system remediation plans focus on nitrogen reduction and nitrogen removal. So one type of advanced treatment system is an aerobic treatment unit, or ATU. So basically in these systems, air is introduced to the sewage with a motorized blower or pump, which increases the rate of solids degradation. So organic matter is degraded more quickly. Elin mentioned that conventional septic systems only remove about 30% of the nitrogen that flows into them. And as you can see, these ATUs tend to remove an average of 51 to 79% of the nitrogen that flows into them. ATUs require smaller drain field sizes, but there are greater operation and maintenance costs, particularly because you're now adding pumps and electricity and other maintenance is required. The picture here is just one example of an ATU configuration. Some ATUs have the septic tank and the aerobic treatment unit contained all in one unit. Just depends on the type that is used. Another example of advanced treatment systems are performance-based treatment systems, or PBTS. These are engineered systems designed for a specific level of contaminant removal. And they do often include an ATU, or that aerobic treatment unit that we just saw. They must be designed by a Florida professional engineer, and the technology used is proprietary. Total nitrogen removal is estimated at about 65 to 97%. So they have a high rate of nitrogen removal depending on the system used. And for more information on approved performance-based treatment systems, you can go to the link that is provided here on the Florida Department of Environmental Protection website. So the final major type of advanced treatment system approved for installation here in Florida are in-ground nitrogen reducing biofilters, or INRBs. They are also referred to as modified drain fields. These systems are passive, which means they require no electric aerators or pumps to treat wastewater, and maintenance requirements are lower than those for ATUs and performance-based systems. The septic system tank is the same as with a conventional system. INRBs have additional nitrogen-reducing media layers that are placed underneath a conventional drain field. These layers create favorable conditions in the drain field for denitrification. Denitrification is a process by which specialized bacteria convert that nitrate, that nitrogen that's in the form of nitrate, into nitrogen gas that can then escape into the atmosphere and not leach into groundwater. It's removed from the system. So how do these systems work? Nitrogen in wastewater leaving the septic tank is largely in the form of ammonium. As it moves from the tank into more oxygen-rich drain field area soil, which is shown here on the map, and then also moves into an additional oxygen-rich zone, which is indicated by this unsaturated nitrification soil here on the diagram, the ammonium is converted into nitrate. And this is the form, this nitrate, that the specialized bacteria need. Once it passes through these two uppermost layers, the nitrate in the effluent passes into a low oxygen but carbon-rich zone to promote denitrification. So here this carbon-rich zone is composed of carbon and wood chips. These wood chips provide the bacteria with energy or food. The bacteria then convert the nitrate in the wastewater to nitrogen gas, which can escape into the atmosphere. Again, this removal of nitrate, converting it to nitrogen gas, and then having it go into the atmosphere prevents excess nitrogen from entering the groundwater and potentially impacting water bodies. So as we mentioned before, only approved advanced septic systems can be installed in the state of Florida. The Department of Environmental Protection has a list of approved systems, which we have provided the link for here. You can also contact your local county health department to see if there are any septic system requirements in the area where you live. With that, I will pass the presentation off to Elin.
Thank you, Andrea. Now let's move to septic system maintenance. Septic system maintenance is largely common sense, relatively simple and inexpensive, especially when we compare to replacing a failed system. It boils down to 4 key components. Properly dispose of waste, maintain your drain field correctly, use water efficiently, and inspect and pump when needed. We'll look into these 4 key components individually. First, properly dispose of waste. Be mindful what you put into your drain. You only flush toilet paper and human waste. No baby wipes or flushable wipes. When you add your kitchen sink, do not treat your kitchen sink as a garbage can. Minimize the use of garbage disposal as you can. Garbage disposals grind big solids into small solids, which will all end up in your tank. Similarly, minimize the disposal of fat and grease into the sink. The scum will rise up to the top of the tank and will not be treated or filtered out. Last is no additives, including these commercial products as well as yeast or baking soda. Research has not found these additives effective in aiding or accelerating the breakdown of organic matters or prolonging the lifespan of your septic system. Second, maintain your drain field correctly. The drain field is very delicate in the winter months. Weight from just one vehicle can push the frost layer deep into the soil and prevent effective wastewater treatment. Fortunately, we do not have harsh winter here in Florida, but anything heavier than a lawnmower can still compact soil over the drain field and prevent effective treatment. Good vegetative cover, such as grass, is important for drain field maintenance. This cover helps the system remove nutrients like nitrogen and phosphorus by using them for plant growth. Grass should be mowed regularly to encourage growth without using fertilizers. Here are some tips how to maintain your drain field correctly. Do not drive or park anything heavier than a lawnmower over any parts of your system. Do not plant trees or shrubs near or over any parts of your system. Do not cover the drain field with additional soil if wastewater surfaces. Do not use fertilizer over drain field. Do mow regularly over the drain field, and do divert surface water runoff from roofs, driveways, downspouts away from the drain field. The third component is use water efficiently. Minimize water use will keep solids well settled on the bottom of the tank. So water conservation is the key. Last, inspect and pump the system when needed. The pumping process should remove all scum, sludge, and liquid from the septic tank. It also requires flushing and back-flushing liquid content to ensure no floating scum is left in the tank to plug the outlet or enter the drain field. The tank should be pumped through the manhole instead of the inspection ports. Pumping through the inspection ports could damage the buffers in the tank and result in wastewater flowing directly into the drain field without allowing solids to settle out. Frequency of pumping is affected by the size or capacity of the tank, the amount of wastewater entering the tank, and the volume of solid in wastewater. This chart from the Pennsylvania State University Cooperative Extension Service gave some general guidelines regarding pumping frequency based on the tank and household size. A system with a larger tank, fewer people in the household, need to be pumped less often. On the other side, a smaller tank with more people in the household will need to be pumped more frequently. Pumping frequency are estimated in years. The figures assume there is no garbage disposal in use. If there is one in use, it may increase pumping frequency up to 50%. So for example, let's look at the tank size at 1,000 gallons. And we say 5 people living in the house. You do not use garbage disposal, then you need to pump it every 2 years, like it shown in the chart. If you do use garbage disposal frequently, you may need to pump it every year. Here are some links to additional resources. Besides the Florida Department of Environmental Protection, UF-IFAS has developed a septic system education webpage too. The screenshot on the right shows you a list of the primary content. With that, thank you for your time. If you have any questions and comments, do not hesitate to reach out to us.